go. Now the slides are working. So just again, just to introduce myself again, my name is Stephen Reed. Co-presenting with me today is Jim Morris, and we're going to talk about unstructured data. And we got a couple things that we're going to share with you today. So just to kind of give you a preview of what we're going to talk about, I'm going to talk about very briefly about the problems or the challenges around unstructured data and why so many organizations and technologies out there that are trying to crack that problem. Then we're going to move very quickly into our first of two demos. Jim's going to have a demo where we're going to try to solve an unstructured data problem using GenAI alone, and that probably won't work the way that we want it to. And then I'm going to get back up and talk a little bit about how taking a semantic approach to your unstructured data and really looking at context, and we'll probably hear this theme throughout our talk this afternoon, how context is really king, and how context is important when we're really analyzing a document and trying to figure out what's going on. And then we'll go back, do a second demo where we're actually going to basically use Semaphore to provide a contextual / semantic understanding of the document and get a different set of results. Yes?
Sorry, I'm going to ask this stupid question.
I love stupid questions. Yes.
Save me a lot of note taking.
Yes.
Is this presentation going to be available later in its entirety?
Yes. We'll have recordings. No. We have everything's going to be recorded, and I don't know if the decks will be available, but obviously the slides will be available on the video. I get tired of listening to myself talk, so if you have any questions, feel free to interrupt me. I love to have it interactive. Okay, with that, I wanted to kind of just talk a little bit about unstructured data, and I'm going to make it real simple. I try to keep things really basic when I talk. When we talk about unstructured versus structured data, what do we really mean by that? We're defining unstructured data as those wonderful docs, those PDFs, those chats, those email messages, that notepad files. That is unstructured data. What is structured data? It's the stuff that's in rows and columns of your insert database name here, right, or your Excel spreadsheets. That's structured. We've seen a lot of different quotes and a lot of different organizations they certainly understand that tapping into unstructured data is really important for organizations to do, but lots of organizations, frankly, are just really bad at doing it because you can't typically manipulate unstructured data the same way that you can do structured data. So this is a statement from Gartner, a little over a year ago. Along comes Gartner, this year and says, oh, well, this Gen AI thing is out there, and now organizations are going to use Gen AI to crack all their problems, et cetera. And the thing that I always thought about, I don't know if anyone had this revelation too, when they first started reading all the trade information about Gen AI is, I'm going to lose my job. Who had that go through their head, right, once or twice? And I was thinking about that, like, oh, Gen AI is going to solve all these unstructured problems, and the need for a tool like Semaphore isn't going to be needed anymore. Well, the reality is, hopefully you've seen in other sessions today that that's not completely true. But just for kind of setting up the first demonstration, I'm going to pretend that I just lost my job. And I'm going to, I think I'm going to start playing on the stock market a little bit. And I'm going to see if maybe, maybe I can use ChatGPT to do some research. Jim, you want to help me do some ChatGPT research on stocks?
Sure.
All right, I want to turn things over to Jim for a first demo.
So yeah, you could think of different challenges along that same line, and companies may be using Gen AI now to try to explore new expansion opportunities, investigate new ways to invest in companies, and we may be interested in where, say, as a scenario, let's say we're interested particularly where companies are actually incorporated. And that's important to us in terms of our analysis. So we want to know, the impact of local regulations or examples I have here, like the market capitalization of companies within a specific jurisdiction, or what regulatory policies vary between jurisdictions. So we might want to know that type of information. So the association between a company and where it's actually incorporated is the key. So let's start with something like, let's just see how ChatGPT does in this domain. So let's ask it a question about California. Maybe I'm interested in particularly in tech companies. So let's be brave here and let's go directly to ChatGPT. This is where I'm going to angle and look at the screen over here. And yeah, what is this hard? Where's the screen? There it is. And we'll make sure he's awake. And I happen to have a question formulated here. Can you give me a few examples of companies that are incorporated in California? So let's go back over here. And let's see what it says. So let's see, came back with Apple, Google, Tesla, Walt Disney. You know, it's different every time. That's what's, if you're depending on these things, the answers come back different. But these are all good. They all look like, oh yeah, these are famous companies in California, right? It seems to make sense. It gives a little description. It talks about these are the companies incorporated in California. Now, I did some additional research to look into if this was true or not. And let's go through it together. So Apple incorporated in California? Well, actually, Apple is incorporated in California. In fact, if I go back to the slides, I have a couple other examples, and I'll help maybe visually walk through it here. So let's go back here. It's always a pain when it does that. You got to go here. There. So Apple's the first one. Notice the list is a little different, but it's the same type of set of companies. So Apple, yes, that is actually incorporated in California. How about Google? Yeah. I have a little buzzer sound, but I don't have that hooked up. So wrong. Google's not incorporated in California. Can you guess where it's incorporated? Delaware. Guess where everything's incorporated? Delaware. Netflix. Tesla. I know they moved to California because Elon hates California, moved to Texas, but it's not, why? I mean, it's not even incorporated in California. Snapchat. So, and if we went back to those other companies, Walt Disney, I bet they're not incorporated in California anyway, either, but I didn't specifically look into those. So it got all of these wrong. And so, why is that? I mean, it says right on it, confidently, as it is likely to be, right? Oh, happy to help you, Jim. Here are a few known companies incorporated in California. It's explicitly saying that, and it is explicitly wrong about these facts. And so why is that? Well, it doesn't seem to understand what incorporated means. And so it's missing some kind of semantics. And it's missing some type of context that is in the context it generally uses, which is, the universe of information it is largely, nobody cares about where companies are incorporated, so that's not out there for it to learn from. So that's why we need some context, a semantic context, and an understanding of how a document might be used to make this successful. So with that, I'm going to turn it back to Stephen to go into a little more detail.
I wonder if there's a better way of doing this, do you think? All right, so I'm sure you've seen various versions of this slide, either today or others, but really what happened is the last one there is understanding. ChatGPT did not have an understanding of the question that we're really asking it, and because of that, we got the wrong responses back. But the fact of the matter is, even if you're not kind of like actively going down the generative AI path, and you've just got unstructured data, and you're trying to wrestle with how do I get unstructured data, there's still a lot of fundamental challenges just with unstructured data itself. Some of those include organizations typically have their own data language, right? You typically have your own way. I worked for a company one time that had acronyms to describe acronyms. I don't know if that, is any of the organizations here, but, I've been in those situations before. Those different data repositories will have different ways of talking about them. So there's no enterprise category. So even though I have unstructured data repository 1, unstructured repository 2, because I don't have a way to have a common vocabulary between those two, I can't really link that information together. Anyone involved in public-private partnerships, we see this a lot. I have one of my clients has to report on basically an industry vocabulary, if you will. It's like they generate reports in one format, but the government is telling them, well, you really have to put it in this other format. So there's other external vocabularies that are being pressed upon you that you have to comply to. And then finally, whether it's acquisitions or just organic growth, data growth rates are just absolutely staggering. So this probably typically gets worse over time and not easier. So then the question becomes, well, is there a better approach? Is there a better way of doing this? And yes, there is, and hopefully you've heard it not only from myself but from others, is we need to add a semantic approach to information. Now, when I first started trying to grapple my head around what is semantics, it seemed like a fairly weird term to me, and I was trying to understand exactly what it is. So I found this video. It's a minute long, and it kind of highlights what are semantic challenges that we have on a day-to-day basis. So take a look at this. Maybe some of you can relate to it. Oh, no volume? Oh, no volume. What happened to the volume? Oh, I know why.
Well, I asked her
I'll start it over.
tonight, and she said, "Do what you want." All right.
All right, try one more time.
Hello, husband helpline. Hi, I need some help interpreting something my wife said. I can transfer you to one of our translators on staff. Thank you so much. Husband helpline, wife translator division. Hi, I need help with the translation. Of course. What did she say? Well, I asked her if I could hang out with friends tonight, and she said, "Do what you want." All right. And was this via text or in person? Text. So our system is bringing up a couple of possibilities. It seems like there's a 55% chance that "do what you want" in this context actually means you better not even think about hanging out with friends. 55%. Meanwhile, there's only a 15% chance that it actually means do what you want. There's also a 30% chance that she actually secretly wants you to go so she can have the night to herself. Okay, so what do I do? Well, it's a 45% chance you should go, a 55% chance you shouldn't go, and a 100% chance that you made the wrong choice.
It's all about the context. What did she really mean? My wife sent me that video, by the way, just in full transparency. So we all have hopefully a working definition of what semantics is, right? It's really the meaning and understanding behind what are things are being said, or the meaning behind our data. Well, how do I take a semantic approach to my data? More importantly, how do I take a semantic approach to my data? And it's really a 3-step process. And the first is really identifying your vocabulary space. And yes, you can use tools like Semaphore to manage the vocabulary space. But I've seen organizations, frankly, just use spreadsheets and Google Sheets to manage that vocabulary space. And it's a very important thing that you understand this is an ongoing exercise. It's not just something I do once and then I don't do ever again. If you think about it, the vocabulary and terms and the words that you use inside your corporation change over time. So yes, it's an ongoing thing. You just have to agree to, hey, this is something I'm going to commit to as part of my business operations, either as part of your CIO tree, part of your knowledge management group, but it needs to be a fundamental piece of your business. The second thing you need to do is really define the metadata, which are attributes of the things that I'm interested about that are pertinent to my business or organization. Now, there is no one size fits all for this. What's important to one organization or business might be different to another, but depending on your industry that you're in, the actual data that you're collecting, you may have different things that are important to you: people, dates, locations. If you're in research and development, maybe it's test results or scores like that. It's really going to be a bit of industry and use case specific. And then the third piece of it is really, well, how do I basically marry these two things together? How do I take that vocabulary and then apply it to my data. And that's really the concept of tagging or classification. You've probably seen some examples of that today, potentially in some other sections. We're actually going to focus a little bit more on data extraction, which is a form of classification that Semaphore does as well too. And when we get to the next demo, Jim will show you a little bit more of that. So just to run through all this again, just so that we have a working concept of what we're talking about here. What's a taxonomy? It's just a way to organize things. The analogy I always like to use is a grocery store is a great example of a taxonomy. So the next time you think of a grocery store, remember this conversation and the presentation I'm giving today. You're walking into a taxonomy, right? If I'm looking for a steak, I'm not going to the produce department, right? Because it's just how things are organized inside of it. Now, what's important to a grocery store? That would be its metadata. Those would be the attributes of the things that are important inside the grocery store. Now, for example, maybe there's a listeria outbreak, so I have to be able to track through the food chain supply where all those shipments went. So I need to know where the source was, where it was grown, things like that. Maybe just the area, because maybe the area was just said, hey, anything in Northern California. Why are we picking on California, by the way? Anything grown in Northern California that looks like romaine lettuce, we got to pull off the shelves because we believe it could be contaminated, right? So those would be the important attributes or the tags that would be associated with that use case. And then finally, putting those two together, content tagging, right? And whether you call this a pipelining function, a data publishing function, a data ingestion function, it's really all the same context. The statement that I really like to hone in on is it is one thing to import data. A lot of companies import data all the time. It's kind of the day in, day out thing that we do. The thing that I would, I'll say, encourage you all to think about is don't just import the data, import the meaning with the data. How do you import meaning with the data? By giving it context through tags and through attributes that you've defined it in your metadata space. So don't do just another 20 terabyte import. Do a 20 terabyte import with all the metadata associated with it. So then you may be thinking to yourself, does this semantic approach and this LLM approach, are these in conflict with each other? Are these two disparate technologies? The reality is no, they're actually quite complementary. LLM is better in some use cases. Semantics is better than in others. But it's very much a gray area. And I think the best way to think about where to use one or where one is stronger than the other is through a concept of scope. If you think about what LLMs are good at, they're good at generalized vocabularies. They're good at understanding common knowledge. They have a very broad understanding of content. So they're pretty good with that. However, as the scope gets narrower, as the vocabularies get more defined, as the data gets more private, that's where you're really going to see semantics helping out with that piece of the puzzle. Because no LLM, unless you're building it yourself, no LLM is trained on your data and your vocabularies, right? So the best that we can do is help the LLM understanding what is important to it by providing the right context of your data and the vocabularies that you're using internally. So I'm now going to talk a little bit about, and I know a lot of other presenters have talked a little bit about Semaphore, but to kind of set up the next demo, I just wanted to kind of give an overview of what Semaphore was and basically the piece of Semaphore that Jim's going to be demoing next, because Semaphore is a platform. I do like to stress that with clients. It's typically integrated with at least one or multiple applications. By far and away, the two applications that we integrate with the most are enterprise search and content management systems. The fundamental reason there is they have the same problem, which is lots of data and no one can find anything. So if you've got one of those situations where you have lots and lots of data and no one can find anything, that's a great place to insert a semantic approach to your knowledge management space. So the three pillars, the three services that Semaphore provide are an enrichment classification service, basically we're applying metadata tags. What Jim's really going to be focused in on his part of the demo is a data extraction server. So we're actually going to extract out the real states of where these things are incorporated. So not only can Semaphore apply metadata tags based on your vocabulary, it can also extract out facts that are also defined by your same vocabulary. And then the third leg of the stool, Semaphore has the ability to harmonize data. We like to use the term harmonization typically in contrast to data normalization. And the example I always like to give here is think about the situation where you have multiple databases and the way that a concept might be stored across those multiple databases. So the example I love is social security number. How many different ways can we think about the concept social security number? Well, in one database, it might be stored as EIN, employee identification number. In a different database, it might be stored as TIN, taxpayer identification number. But in my content management system and in my employee record, it's inside a PDF and it's stored as social space security space number. It's all talking about the same concept. It's just being represented differently. So with our kind of data harmonization capability, you can leave information in its system of record, and you can have applications say, hey, I want the concept of social security number from this database. Well, inside that database, it's stored as TIN, but the application doesn't need to know that level of granularity. So now you can start developing applications around business speak, around concepts, not necessarily SQL statements. And that's really a really powerful feature of Semaphore as well, too. So, again, just to kind of talk about setting up what you're going to see next, there's basically three pieces of Semaphore. There's a data modeling component. I know Lance spent a lot of time that in the last session, so I won't go into much of that. So that's basically where all your knowledge models are stored. Underneath the covers, it's a taxonomy/ontology management system. You don't need to be a taxonomist or ontologist to use it. It's all GUI driven. And then there's basically the services, the data classification service, and also a native integration service, meaning I can publish out. I was just talking to a client yesterday about this. I can publish out the taxonomies or vocabularies stored inside Semaphore to other applications. So you think of the situation, and very simplistic, you're just trying to contain a controlled list of all the states in the union, right? Do we use the two-letter postal abbreviation? Do we use the full, spelling, full name of the state? What do we do, right? Well, Semaphore can be your single source of truth for that. So basically, you can have an application. The application can say, hey, listen, I need to basically paint this dialog box, and I need a drop down of all the states. What is the corporate standard of how we represent states? Oh, we use the two-letter abbreviation. That's what Semaphore returns to you. But again, the application developer doesn't need to know that. You can basically use Semaphore as that single source of truth of the vocabulary space within your organization. So with that, we're going to set up demo number 2 and see how we're going to solve the same problem, but this time using semantics. Jim, back to you.
Thanks, Stephen. So, yeah, just to harken back to what we were saying before, why did ChatGPT get these questions so wrong? And we said before, it's really about context, and that's what Stephen was emphasizing as well. And so we need to give Gen AI more context. And this is, we're using this a particular example here, but you can imagine what this is like in your own organization when you're trying to use your own context and documents to inform what these systems do. And the context these systems have is very broad. They're very good at what makes them seem so miraculous is they're so good at understanding the language. Well, that's because all there is language. It's all sorry, I think I was getting a signal from the back. No? Oh, sorry. Sorry. Okay. So that's how it has so much information just about the language. That's the context it has, and that's how it's able to form sentences so well, based on these probabilities that it uses. Jurisdiction, as we said, is not a common idea, so that's the problem. And it needs context. So what context does it need? And I'm going to suggest that the context is documents. Documents, documents, documents. And you think, oh no, I just need the data. You actually need the document because the document has the context for the data. And as a librarian, in all seriousness, documents are what we're about. Documents, books. This is what we've trained our entire career to manage. And when the conversation starts drifting away to, oh, just give me the data, give me the data, you're throwing away the context. Unless so why do we still sign documents? I signed a corporate compliance document just the other day. We signed bank agreements, we signed mortgages. We're constantly using a document saying, I'm signing this thing on page 5. It replies to the entire document. So there's something missing from this question, and I'm suggesting it's the document. Because if you think of where is this jurisdiction thing actually recorded? It's recorded in a document. It's recorded in a filing that the company has to register with the SEC every year. It's part of their annual requirements. Or, the document where they were incorporated originally, when, their documents of incorporation, whatever. That's where this information is actually officially documented. And I have lots of examples of documents, but I'll move on. So if we think about this particular question, so we have these 2 sample documents, 2 examples, these 10K annual filing documents, for example. And here's one right here. I don't know what 10K stands for, but it's probably like 10,000 pages because they're extremely long. And right at the top, it'll tell you the name of the company, which isn't always obvious. Here's the state of jurisdiction. So that's the information we're looking for. It's in this little blurb right here. And we're interested in their profitability, their market capitalization they report. That's buried down here in this string of text, somewhere later in the document. But the point I want to make is these things that we find in the document, they're relevant to all 10,000 pages. So if you're looking for a piece of data that's on page 100, you have to know that it's talking about a company called this and a company that's incorporated in this state. That applies to the entire document. And this is precisely the type of context that an LLM is missing. And even in RAG solutions, where you're taking your own documents and sending it to the LLM, you're chunking up the documents. Chunk. Why do we use such derogatory terms? It's document. Let's chunk it up. Who cares about the document? So we've got all these chunks and all separated, and the LLM doesn't care. It's going to make its sense of across the whole thing. So what we can do, what Semaphore can do, and I'll show you how I do it, is take a document like this, pull out the pieces of information that are the key elements that tie all the chunks across the document together, and we can send that with the prompt. That's part of what people talk about when they talk about graph RAG. In our RAG solutions, we will often send the taxonomy, we'll send the variations on the terms, just like Lance was showing in the previous session. That can all be context we send to the LLM. But we can also send essentially a graph that informs the basic facts that we need from this document, the facts that correspond to the types of questions we're trying to answer. And that's the context that we're talking about. So I'm going to show you how we would extract this information from using Semaphore. So let's go over to Semaphore. Reverse my information here. Let's make sure we're awake. And you've seen Semaphore before, so you know that we have a bunch of models. This is very big, but hopefully you can see that. I'm not going to try to make it smaller. So you can see we have these different models. And so we're using a couple different models. So models, knowledge models. What does that mean? I like to think of what we're doing with semaphore. What's the first thing you need to do? You need to model what you know. That's it is. That's all a taxonomy is. It's not some freakish scientific craziness. You're just writing down what you know. And you need to write it down with different levels of precision, perhaps. But you're just documenting what you know. That's why we call them knowledge models. You're modeling your knowledge. So when we're asking this question, I need to extract this type of information from a document. What do you know? Well, one of the things we know is kind of traditional taxonomy type information, and we have a specific taxonomy for that. For example, this is very simple. We have some terms like the principal roles that might be applied in a 10K type document. Different roles that might be found. These are all things, other different types of facts we might be looking for in a taxonomy. And something as simple as CFO, well, it might be people in that document might be listed as the CFO, or they might be listed as the Chief Financial Officer. So we can manage different types of labels. Classic taxonomy 101 stuff. Very simple. But we can actually use this information. So we know this stuff. This is known stuff. We know what states there are. We know the variations of how states might be referred to in documents. But we also know what we're looking for. So let's go to another model, again, using the linked data capabilities of Semaphore. You can see I have a lot of models linked into each other. So it's really a vocabulary network, if you will. And I'm going to go to what we're calling a fact extraction model. And this is where we model some additional types of context. And if I can find the open button. So here we have the taxonomies that we were just using. Those are all still in here. And we're going to put them to work against other contexts. So for example, what am I looking for? I know what I'm looking for. So that we put into the facts that I'm looking for. So I'm trying to extract the jurisdiction, 10K jurisdiction, the market capitalization. Maybe we have their officers are listed. Let's find those and get their names and their roles, stuff like that. And we have some other facts that we're using for different types of extraction strategies. So these are all in here. So this is very simple. What are we looking for? And then the third part is we model the context of where this information is. So I know something, I've determined that we do have a type of document type that has these types of facts I'm looking for. So I'm going to model enough context of that document to be able to find that information. So for each of these things I'm looking for, I have what we call an extractor. And we model it as simply as we possibly can. And we have, for example, jurisdiction could be a couple different things. We could actually be corresponding to a vocabulary, or maybe there's some information there that we don't recognize. So maybe we'll just extract what's there, because it's supposed to be a location, but we don't recognize it. Maybe it's spelled wrong, or it's an OCR document that's not clear. Let's just extract what's there, and we can name it as such. And if we go into this, there's a whole different story about how we build these extractors. But it's essentially knowledge model. We're modeling what we know. We're modeling what we know about the structure of a document. We're modeling what we're looking for. It's knowledge model management. So now let's look at how we can apply this model. Checking time. So let's go to a tool that we have that allows me to look at this is fun. That allows me to look at a specific document, and we'll see what gets extracted from it. So I've got a bunch of 10Ks here, just as examples. Let's open this one. And I'm going to send this to Semaphore, which is going to use that model to make some determinations about it. Again, this document's probably 10,000 pages long, so we'll give it a second. But what we'll see is Semaphore coming back with the information that it sees in the document and the specific facts that we've extracted, including the capitalization, the name of the company, even some information like who's on the board of directors.
Excuse me, these PDFs are just like computer generated with all the text intact. Like it's not a scanned image, right? It's a text.
It's a PDF printed from the SEC website. Yeah. So, I mean, it's a fair point that I'll admit to. If you go to the SEC website, it's done some of the extraction for you. You can actually look at the document and it will highlight certain data elements. And you may be able to use that database query. So we're really talking about an example here, and apply it to your own types of documents that have these similar types of challenges. And here we are. So documents on the left, on the right, we can see we've identified the jurisdiction for this company, surprise, is in Delaware. And we can look to see where that evidence is coming from if we wanted to. But we've also extracted the market cap, and we've some information about it, the capitalization that it gets reported, and the type of analysis it used for common stock in this case. So this is, I like to use this example because it's not, where the jurisdiction is. Well, there's a pretty clear anchor. It's a form, so it's going to be near some standard text. So it's not easy, but it's conceptually you can get how you might model that. Capitalization is just in a paragraph somewhere. So identifying where that, you can imagine the amount of numbers in this document. You're looking for not any number, you're looking for that number. So you need to understand that context. So we're modeling things about language, like how would these documents express something about this is our market capitalization? Would they say that, or would they use some different terminology? So there's different ways to collect that information. Maybe you would mine these documents for that type of terminology so that you can apply that to your knowledge model and use it to find similar information. This is kind of cool. We found our officers. We found this guy, who's the president. And for fun, we've extracted the context. This is one of my favorite things, is that when you're doing these extractions, you can also extract exactly where you found it. So if you need to analyze across thousands of documents, and I just need to see this particular piece of element, well, extract the data points, extract the context, and then you're not opening up 1,000 documents to understand this little piece of it. You can just deliver this as a CSV or a spreadsheet or in some other type of interface. So, last part of the story. This is all inside of Semaphore's tools. How could we apply this? Well, we have a system that we developed where we've taken this data for the collection of these 10K documents, and we've put them into a search system. And I'll let you guess which database we may have used for this search interface. That's right, MarkLogic. So it's a MarkLogic-based database, which is perfect for these types of things because you can store documents in many different ways. So if I wanted to open up Apple's huge. Let's just open up the HCA document again. So here we've got the PDF is in MarkLogic, the HTML rendition that MarkLogic creates of the document, the RDF view of the data that we've extracted. So Semaphore can generate these extraction data about the jurisdiction and capitalization, put it in triples, store it in MarkLogic, have it associated with the other forms of the document. So now I can do a text search and say we're looking for California. Say I have a whole bunch of 10Ks in here and say, okay, let's find the ones that are located in California. So I'm going to type California and do a search. Well, what do you know? They're all in California. Because every company has something to do with California in these giant documents. So that's not going to help us. What I need is the specific facts. So with MarkLogic, I can treat these things, all this as a database, that I can do more specific types of filters, like, okay, just show me all the organizations and the market capitalization value that we found. And I might as well have the name of the company as well, which is the reporting entity. So now we can see in our list, yeah, sure enough, most of them are in Delaware. There's Apple in California with, like, a bazillion dollars, and one's in Michigan. So now we've got more information that we could use, not just for Gen AI. This is stuff that Semaphor's always done. And when paired with MarkLogic, we can do this kind of stuff. But it lends itself to the whole Gen AI application as well. This is the context. This is information we can extract from these documents and send with the documents to the LLM. So it has not just the chunks of text, but the graph, the data that provides the necessary context to answer the questions that we're asking. So just one other example, I'll go back to the presentation, and before I turn it back over to Stephen, and so, generate just standard business reports for business intelligence. So as I'm, still in my pajamas, drinking my 5th cup of coffee at 2 a.m., I can generate a report and get a better feel for how to invest my last $300. But with that, I'll give it back to Stephen. Thanks.
All right. One of the ways I like explaining fact extraction that Semaphore does is hopefully everyone's used like a pivot table or a BI tool, right? Everyone's familiar with those types of tools on structured data, right? I can point a pivot table at a bunch of rows and columns, and I can run reports like this all day long. What if I could do the same thing on a content management system, right? I can point a BI tool now at SharePoint and generate something like that. I think that's a very powerful thing of the ability to unlock information inside of unstructured data. A lot of times, companies will just gloss over the facts, the information that's locked up in unstructured data. But with a tool like Semaphore, I can now basically surface that information and run reports on it. So I just got one more slide, and then we'll open it up for Q&A, but I just really kind of wanted to wrap things up. Thank Jim for those great demos. They were really fun to watch. But when we think about what are some of the benefits we talked about here today, it's really when we have the ability to connect disparate data sources across different data repositories and silos. Again, whether it's structured or unstructured, it's kind of agnostic to us. Data is data is data. But when you're focused on the unstructured data problems, having a common vocabulary and way to talk about things is paramount. The other thing too, and I'll say some of the government clients I've spoken to, is the speed of data analysis is also getting more and more important, right? How long did the last ETL take, right? If I can tag data at ingest, I can now start doing things with it much, much faster than I can if I just I've just uploaded 20 gigabytes of data. I don't know what it's about, but I just, so now I can basically make that information now very quickly accessible to other applications and speed my analysis time. It reduces the needs to do ETLs at all, right? And will potentially also save some of our data storages costs, so I don't have to do as many data normalizations functions if I'm just extracting out the things that I really need to know out of my unstructured data. It provides, the magic word of today's session, context to your datas that LLMs natively cannot, right? So we showed how we can extract out the area of incorporation, the market capitalization, and that context is valid for the next 9,999 pages of that 10K filing document. And finally, you can improve the results of your LLM. So whether you have an LLM strategy in place right now or you don't, taking a semantic approach to your documents can help you in both scenarios. And with that, we'll see if there's any questions in the room. Thank you so much. Any questions? thoughts? All right, well, Jim and I are here for the remainder of the day. If you have any questions, like to talk about a specific use case, want to learn more about Semaphore and its entity extraction capabilities, we'll be happy to talk to you. Thank you so much for coming today, and enjoy the rest of the sessions.